Hello everyone, welcome to the Circuitscape tutorial. Before we begin, please ensure that you have downloaded the tutorial data package, and in it you should find the folders and data layers relevant for our tutorial, and also the software zip folder, the tutorial guide. As you can see here, this would contain all the steps and screenshots which will be helpful for you. Feel free to pause this video at any time and refer to this document if you need a more detailed explanation. I've also included the GraphHab Circuitscape tutorial ArcGIS package, which you see here, and it would contain all the files and layers that we'll use for the tutorial, including the ones that have been pre-processed, just so that it will make it easier for you to run Circuitscape on your own. All right, now that that's out of the way, let's begin with the first step. So before we start, usually I would advise students to prepare the workspace, and in this case, I will prepare my workspace by adding the folder. So in this case, I would add the tutorial data package. So let me go back here. All right, I'll add the data package into the folder connection. And here you can see the relevant folders. All right, now let's begin. So after preparing your workspace, we would prepare the geoprocessing environments as well. So if we go to analysis and under geoprocessing, select environments. So here by default, I like to set my coordinate system because that usually never changes. In this case, we're using the Australia Albus. And you can also set the cell size, mask, and snap raster here. But for our case, because I want to demonstrate it in the tools later, so I'm going to leave this blank for now. All right. Now we move on to the first pre-processing step. So for Circuitscape, we would use the resistance layer that we used for the GraphHab model run. So if just to refresh, for the GraphHab model inputs, we have the habitat and the species resistance layer. So for Circuitscape, we can't use the resistance layer from the GraphHab model inputs because the pixel values are very large. So for Circuitscape, it actually runs faster using smaller resistance values. So what we're going to do is we're going to convert these pixel values from the GraphHab resistance layer back down to its resistance multiplier value. So we do this by dividing the values by the pixel value, which is 20, and we'll get the resistance multiplier. And to do this, we'll use the raster calculator tool. All right. Now, the first thing we'll do is we'll select the float operator from the under tools in the math group. Double click on that and the float should appear in the formula tab. The reason we choose float data type is because it's able to store pixel values with fractional numbers and basically any numbers with decimal places. Because we know that our resistance multiplier may contain decimal. For example, the 30, if we divide it by the pixel value, which is 20, it will get 1.5. So if you don't specify the float, the data output will not be able to store this decimal value. So that's why we use the float. Now that's out of the way, the next step is to select the resistance layer from the GraphHead model input. So there you go. And then we'll divide the value by 20, which is the pixel value. And again, you can check this in the properties under the source and raster information. Here you have the cell size, which is 20 meters. Okay. And then we'll go ahead and select the output raster. So in this case, I'll store it in Circuitscape under resistance. And of course, I'll put the rescale in the file name to know that this is the rescale option. All right, feel free to rename this however you want. And we'll go ahead to the environments. Now we'll set the processing extent. So if you noticed, the extent that we use here is smaller than the extent that we use for the GraphHead model run. So just a comparison, let me drag in one of the layers from the GraphHead model run. So this is the G2H study area. And the reason why we're running it at a smaller scale is because, as explained in the tutorial guide, so in section B, it takes a very long time to run Circuitscape at this large of an extent. So for the sake of running this tutorial at a faster speed, we have clipped the data layers to a smaller extent. This is just to help you learn how to pre-process the data and run Circuitscape smoothly and at a much faster rate. All right, I hope that clarifies. So let's go back to our geoprocessing. So for the environments, the processing extent will be at this new extent which we call G2H mini. And you'll find the layer that we need for snapping in the general folder and land cover for snap G2H mini. So that's the file that you see here. So we'll set that for our processing extent, cell size, mask, and the snap raster. All right, now that is done, let's click run. And by default, you will see that the output would have this stretch format. You can go to symbology, and this is what I mean, stretch. So before we proceed, we need to make sure that the unique classes, as you can see here, has been generated. So what I'm going to do is select unique and then select yes when this pop-up appears. So that will compute the unique values, as you can see here. So I'm going to drag it to my Circuitscape model inputs. And you can see that now the values from the GraphHead resistance raster have been converted to the resistance multiplier value. So before we proceed, just double check the values to make sure that it aligns with the GraphHead resistance values. So yeah, that looks correct. And also, just in case, double check the raster information. So I double click the layer and go to source. Make sure the columns, rows, and the pixel cell size is accurate. You can also check the spatial reference, make sure the coordinate system is in order, and select OK. All right. Oh, before we move on, I would just like to highlight that we've included these troubleshooting tips just in case any additional class has been generated from the previous step. So you can refer to the tutorial guide. And in this case, because the output looks good, there's no issues with it, we can skip this section. Now we move on to the next section, which is the habitat layer. So We won't use the habitat layer from the GraphApp input. Instead, we will actually use the patches that was generated from the GraphApp modeling run. So for reference, you can navigate to your data package under GraphApp. You'll see this species XV1 folder. So this is an example of the GraphApp output that we'll get from the first tutorial. And here you can see the patches shapefile. So under normal circumstances, we would use this shapefile. But as you can see, this is for the full G2H extent. But for our case, I've already clipped this shapefile into the current extent that we're using. So for that, you can navigate to the Circuitscape under Habitat, and this is the patches, as you can see here. So for this tutorial session, please use the patches under the Circuitscape folder. All right. There is no additional processing step for this. I just wanted to clarify where I got the data from, and that is from the GraphApp modeling run. All right. So that concludes the end of part 1 of the Circuitscapes tutorial. All right. One more thing that I forgot to mention is that when you need to get the GraphApp matrices, for example, for these details, you can access it by going to Open Project, so File, Open Project, and navigate to the folder of your GraphApp output. So in this case, I have already stored mine in my Dropbox. Processing. Okay, so let's use woodland birds as an example. If you go to the folder that you use to run GraphApp, so in this case it's woodland birds version 2. What I would do is navigate to it and open this XML file. And this should pull up the outputs that you got previously. And in this case, what we want to do is we will go to the global matrices. So if you go to metrics and then go to global metrics, here you can select, for example, the mean size of components that would be accessible here. And once you click that, click OK and give it some time to calculate. And this is the output. So I would copy that and paste it in my Excel. So next would be repeat it for the size of the largest component. And there you go. All right. And for the next one, number of components. Okay. And the IIC value. As for the patches and links, that is, let me check. I think that is what we need to get from ArcGIS. But the total patch area, yeah, so okay, so those are the data that we can get from GraphApp. For the patches, I'll just open up my ArcGIS and so the first one would be the number of patches. Here I would just go to the attribute table and you can see here the number of patches is 1816. And for the links, I would go to the edges, the least cost path. It should be the same for edges and least cost path, so it's 4664. And for the total patch area, I would go to patches, and if you can see there is the area column. I would right click on it and get the statistics. And here you can get the sum of the area. I believe if you use summarize, oh no, yeah, so statistics is good enough. So here you can get the sum. And I would copy that and paste it here. So that is how we get the numbers for the table that we usually use to compile the results. Okay, hope that helps. And also just want to highlight that that's why it's very important to make sure you store the um, GraphHab output folder in your as part of your database, and don't delete it first until you've gotten all the information that you need.